Hi and Assalamualaikum. Ammonia, a colorless gas with a distinct pungent smell composed of nitrogen and hydrogen with the formula NH3. The ammonia molecule has a trigonal pyramidal shape with three hydrogen atoms and unshared pair of electrons attached to the nitrogen atom. It is a polar molecule and is highly associated because of strong intermolecular hydrogen bonding. Did you know that ammonia have many uses? Ammonia is widely used in the making of fertilizers, wastewater treatment, and also in the making of explosives. But how is ammonia produced?
But how ammonia is produced? On an industrial scale, ammonia is produced from a reaction called Haber process, whereby nitrogen is combined with hydrogen to produce ammonia. And this reaction is a reversible reaction. N2 plus 3H2 equal to 2NH3. This method of producing ammonia was introduced by two German chemists, Fritz Haber and Karl Bosch, during the World War I. Haber process is conducted at 400 to 450 degrees Celsius and at a pressure of 200 atm in the presence of an iron catalyst. The temperature and pressure used in this reaction can be explained using the chemical equilibrium concept. Le Chatelier's principle tells us that increasing pressure will favor the site with fewer moles. So, in the production of ammonia, it makes sense that a high pressure is used so that a greater yield of ammonia is produced. However, it is expensive to build a plant that can withstand such a high pressure, and that is why a pressure of 200 atm is used. The production of ammonia is exothermic, which means heat is released, and according to Le Chatelier's principle, lowering the temperature in an exothermic reaction will shift the equilibrium position to the right, which is toward ammonia. So, a greater yield of ammonia will be produced by using a lower temperature.
There are two common methods for producing hydrogen, which are the steam-methane reforming reaction and electrolysis. The steam-methane reforming reaction is an endothermic reaction involving the reaction of methane and steam, which is conducted at 700 to 1000 degrees Celsius and at a pressure of 3 to 25 atmosphere in the presence of a catalyst to produce hydrogen gas, carbon monoxide, and a small amount of carbon dioxide. This mixture of gases is called synthesis gas, and we will talk more about this later. The temperature and pressure used in this reaction can also be explained using the chemical equilibrium concept. This reaction is an endothermic reaction. According to the Le Chatelier's principle, increasing the temperatures of an endothermic equilibrium system shift the equilibrium position to the right so that the added heat can be absorbed. Hence, a high temperature of 700 to 1000 degrees Celsius is used in this reaction so that the reaction favors the product and a greater yield of hydrogen gas is produced. Other than that, Le Chatelier's principle also tells us that decreasing pressure will favor the site with larger mole. In this case, only 3 to 25 atmosphere of pressure is used so that a greater yield of hydrogen gas is produced. The enthalpy of reaction for the steam-methane reforming reaction at 25 degrees Celsius can be calculated as follows. The enthalpy of reaction is equal to the sum of enthalpy of formation of products minus the sum of enthalpy of formation of reactants. So, the enthalpy of reaction for the steam-methane reforming reaction at 25 degrees Celsius is positive 206.17 kJ per mole, which shows that this reaction is endothermic and heat is absorbed.
So the function of methanol is measured to be fuel for car, either to be mixed with fuel or in the fuel cell. So the methanol molecule have a tetrahedral shape with two geometric center which are carbon and oxygen. The synthesis gas form methanol. The product between the steam-methane reforming reaction, which is the synthesis gas that consists of carbon monoxide, hydrogen and small amount of carbon dioxide, will react to produce methanol. So the reaction is an exothermic reaction with a temperature between 200 to 300 degrees Celsius and the pressure between 40 to 100 atm. So the catalyst used in the reaction is alumina pellet coated with copper and zinc oxide. So the catalyst is used to increase the rate of reaction, which is the production of methanol without getting consumed the catalyst in the process. The methanol synthesis process can be described by three equation reaction.
Equations 1 and 2 represent the exothermic hydrogenation of CO2 and CO to methanol, and equation 3 represents the water gas shift WGS reaction that is activated by the copper-based methanol synthesis catalyst. As reaction 1 and 2 are exothermic and result in a reduction of molar volume, methanol synthesis is favored at low temperatures and high pressures. However, sufficiently fast reaction kinetics requires temperatures above 200 degrees Celsius, and methanol composition is thus limited by the thermodynamic equilibrium.